So, good afternoon, everyone. I'm Thailand Nakarta, working as a principal engineer at Huawei. Today, we're gonna talk about Huawei Cloud MRS service, which means MapReduce service. It's a managed big data service. If you are ready, we can move. So, let me share my presentation. Can you see my screen? I guess so. Maybe verify it with my colleagues. And you can also type it to the chat box. Give me a second. Gözüküyor. Okay. It's visible, yes. All right, perfect. So, if you are ready, we can go. Yeah. So, we're gonna talk about big data analytics, and the managed service of Huawei Cloud MRS MapReduce service today. But first things come first. A few forwards about today's session. As you mean or you may not mean, there is some terminology definition for the big data. Big data refers to the massive volume of structured and unstructured data, and we can even add semi-structured data that generated from various sources such as social media, IoT devices, business transactions, etc. Current trends in big data include the rise of AI-driven analytics, real-time data processing, and cloud-based solutions for scalability. And there are also many key challenges when dealing with big data, such as data privacy, ensuring data quality, and addressing the complexities of integrating diverse data sets. So, overcoming these issues is essential for businesses to derive actionable insights and maintain competitive edge. With Huawei Cloud MapReduce service, MRS is a robust cloud-based platform for processing, analyzing, and storing, of course, vast amounts of data. And MRS can offer scalable storage and powerful computing resources and user-friendly tools to handle complex data tasks efficiently. So let's move. Today's objectives upon completion of this training, this presentation, you will have a good command of definition of MRS, have a good understanding what big data is and its potential, understand the main principles of MRS, of course, and be able to describe the process and advantages of MRS. So, let's give a brief description about big data, an overview. Data is big, yeah, as we know. The endpoints, the mobile phones, the endpoints are increasing exponentially in the last decade, and the data is growing exponentially as well. Today, in last year, in 2023, 120 zettabytes of data in transaction in the World Wide Web, and this number will be more than 200 zettabytes data at 2025. And another information about this data, in a single day, there are 328 million terabytes produced from the endpoints daily. Yeah, it's more than 300 terabytes producing data. And I must add one thing, the data that the metric that I said priorly, I mean 300 million terabytes data is only the online data. We don't know the exact amount of the offline data. I mean the data that stored and processed in the private networks. Okay, I and if we add these offline sources of data, the data is very huge to handle, to store, and to process. So another example for that, the New York Stock Exchange is an example of big data. 3 years ago, information says that NASE generates 1 petabyte of trading and funding data per day, only one day. So as you can see, there are some info about the every minute of the day in a web. As you can see, there are more than 3,600 photos, videos shared in Instagram in a minute, or in the YouTube, users upload more than 40 hours of new video to the YouTube. So as you can see, data is growing. But we need to define big data in some metrics, some definitions. As the experts and the community, the technology guys says, when we define the big data, we need to use three main metrics. They are volume, variety, and velocity. Over time, other V's have been added to descriptions of big data. Volume means the amount of data from this different sources, myriad sources. Variety, the types of data, I mean structured data, semi-structured data, unstructured data. Structured data means such as transactions, financial records, mainly from the relational databases, OLTP data. OLAP data are are the examples of structured data. For the unstructured data, such as text, documents, and multimedia files, we can give social media users. Social media accounts are the examples for the unstructured data. And for the semi-structured data, you can give examples such as web server logs, JSON files, streaming data from the sensors, etc. And the other V is the velocity. It means the speed at which big data is generated. And this speedy data must be processed and analyzed. In many cases, big data sets are updated on a real or near real time basis. I mean, when we are talking about real time, it must be under 20 milliseconds, okay? 20 milliseconds. So if the data coming from a source, I don't know, maybe an IoT sensor, maybe from a web server log, and it coming continuously, this means this data has a speed, has a velocity, and we can define as that source as a big data source. And for the veracity, this means degree to the which big data can be trusted. I mean, the data sources must be verified, must be trustable. And the value, of course. Value for the big data is very important thing when you want to work with big data, because as you know, when collecting and storing and processing big data, you need to have a lot of resources, and if you don't derive a value from these big data, if you I don't know, maybe let's say if you don't harvest any valuable insights from this big data process, there's no meaning to proceed further. So the value of the big data is important as well. And when defining the big data, the value as well as the others is an important pillar. And last, the variability. It means the ways in which the big data can be used and formatted. So after some definitions of the big data, let's proceed with the real life examples. Companies use big data in their systems in the last decade to improve their operational efficiency, provide better customer services, and create personalized marketing, customized marketing campaigns, and take other actions that can increase revenue and profits. And businesses that use big data effectively hold the potential, of course, in the competitive advantage over those that don't, because they are able to make faster and more informed business decisions. So, for example, big data analytics, of course, provides valuable insights into customers that companies can use to refine their marketing, advertising, and promotions to increase customer engagement and conversion rates. They can do that by both in historical or real-time data can be analyzed to assess the evolving preferences of consumers or corporate buyers, enabling businesses to become more responsive to customer wants and needs. So, in brief, big data is very critical for both enterprises, small, medium enterprises, public institutions, even you. So, data must be stored. We all know that. And big data is also stored in a data lake. Data lake is a little bit different from a data warehouse. Warehouses are for storing different transactional databases. Okay, but data lake, you can store both structured like relational databases, unstructured like video files, image files, text files, and of course semi-structured file like log files or JSON files. You need to use a data lake. While data warehouses are commonly built on relational databases contain only structured data lakes can support various data types on Hadoop clusters, Apache Hadoop clusters, which we talk about in the upcoming slides as well, or cloud object storage like Huawei Cloud MRS, or NoSQL databases like MongoDB, and other big data platforms such as the, let's say, manage Amazon service or manage Microsoft service or Cloudera, etc. So, big data processing places heavy demands on the underlying compute infrastructure. Okay, you need to have good infrastructure and scalable infrastructure, and of course, available infrastructure. And you need to manage this infrastructure properly if you want to derive valuable insights from your data. So if you, even if you provide this infrastructure capability, you need to monitor them, you need to govern them. All of them are a lot of burden to you, its users. But with Huawei Cloud MRS, we are getting details in the upcoming slides, but with Huawei Cloud MRS, you can only focus on your data, not the infrastructure, not the monitoring, not the logging, blah, blah, blah. Just focus on your data, do your data science, and get your insights from your data with MRS. So, what are the trends for the big data? The experts say the edge computing are booming. Edge computing means the storing resources must be in the vicinity of the data source. So when you want to process your data with edge computing, you will be get fast. So it's a big trend in the big data ecosystem. The second one is cloud and hybrid cloud computing. Because it's very important because when you using traditional data centers, traditional system centers, system rooms, challenging with the, let's say, hardware problems, middleware problems, even electricity and security safety problems. With cloud options, they can be bypassed. So it's very important using cloud resources when you want to use big data and big data analytics. And other term is, of course, the data lakes. It's very important when you want to store your data. And it must be, let's say, must provide in limitless capacity because data is coming and you need to store it, you need to process it. And of course, machine learning and AI. Because when you work with machine learning and AI, you need to have data, more AI accuracy, more machine learning capability. So the last trend about the big data is AI and machine learning. So we have challenges, of course. Big data is usually complex systems. In addition to its volume and variety, it often includes streaming data and other types of data that are created and updated at a high velocity. As a result, processing and managing big data are complicated tasks. For data management teams, the biggest challenge are listed like that: dealing with large amounts of data, fixing data quality problems, integrating different data sets, preparing data for analytics applications, ensuring big data systems can scale as needed, and of course, governing large data sets. So, after giving a brief description about the big data and its ecosystem, let's proceed with the MapReduce, Huawei Cloud MapReduce service. So, what is MRS? As you know, traditional data processing struggles with massive, complex data sets of the today's digital world. As we know, Apache, yeah, I, I must admit, Apache is very nice to have tools, nice to have open source softwares for a lot of problems. And but it's not, let's say, manageable because when dealing with open sources, you may have a lot of problems when integrating different open source tools. Yeah, Apache Hadoop emerged as an open source solution for distributed data processing. However, building and maintaining these Hadoop clusters in-house is very costly and time consuming. So there is so this is the place where MRS takes a role. It's a managed Hadoop service, and MRS simplifies big data processing. It addresses the challenges of building and managing Hadoop clusters by providing a pre-configured, scalable, it's very important, and cost-effective solutions. And users can enjoy full control over their clusters and can easily run big data components like Storm, Hadoop, Spark, Ashbase, Kafka, etc. There are a lot of other Apache ecosystem tools, but since we have limited time, we cannot define all of them, as you know. With MRS, businesses can efficiently process massive data sets, extract valuable insights, and accelerate time to market for data driven applications. So, let's review the MRS architecture. Give me a second, please. In MRS architecture, there are various components in infrastructure side, in data collection, data storage, convert processing, data display and scheduling, and cluster management. They are all bundled in MRS. If you are working with Hadoop, Apache Hadoop, you need to build all of them one by one. And believe me, it's very time consuming. In my past experiences, when I build, monitor, and deploy a Apache Hadoop cluster in a customer environment with more than 20, 25 nodes, it's very time consuming and configurations, pow, it's a very spaghetti. So when I first meet with the MRS, and thank God, it's all okay. So what are the some components are included in the MRS? We have carbon data. It's a native data store format, and it allows you to faster interactive queries over petabytes of data using advanced columnar storage. We have ClickHouse. It's a columnar database as well. We have Flink. It supports batch processing and stream processing. We have Flume. It's for the log collections, aggregation and transmission. We have HBase. We have HDFS, of course. It's a file storage and it's the core of the MapReduce and Hadoop systems. We have Hive. It's a data warehouse, and it provides a series of tools that can be used, ETL jobs or ELT jobs for your data. We have Hoodie. We have Who. We have Impala, and of course Kafka, a very important tool when you want to retrieving and transmitting the logs or messages. If you have stream data and if you need to get this data from a source and transmit a target source, you need to use Kafka. And in MRS, Kafka is already pre-installed tool when you want to use MRS. We have Kudu, we have LDAP for authentication, authorization. Of course, we have MapReduce for data processing. We have OZ for job management, and Presto, Ranger for security, Spark for stream processing with AI capabilities. We have Tez, another data processing framework. We have Yarn, yet another resource negotiator, and Zookeeper for coordination, all of these items and the cluster. So you can see a screenshots from Huawei Cloud Console when you want to provision a MRS service. As you can see, there are some templates for your workload requirement like real-time analysis cluster, ClickHouse cluster, Hadoop analysis cluster, HBase query cluster. When you want to proceed with those templates, just you need to know your requirement about your daily work. If you want to work with real-time, okay, that's okay. You can move with real-time analysis cluster because it's optimized for these jobs. But if you just uh, make some jobs or gain some insights from stored data, you can use Hadoop analysis cluster template. As those besides these templates in MRS, you can also customize your MRS cluster easily with the checkbox, and you just want to check those items for your customized cluster. It's up to you. So the next thing, its key features and benefits. First of all, MRS simplifies big data management with one-click cluster creation, relation, scaling, blah, blah, blah. And of course, high performance. We have compact processors. We have Intel processors. By leveraging those processors, MRS optimizes software and hardware for cost-effective performance. And scalability is very important. Its auto-scaling feature, I mean, the MRS's auto-scaling feature, it's very, very important. Dynamically adjust resources to handle fluctuating workloads and providing cost saves when you want to use Hadoop clusters. And finally, last but not least, flexibility. MRS supports a wide array of big data clusters and pre-installed components such as Hadoop, ClickHouse, HBase, blah, blah, blah. So we have some application scenarios. Large-scale data analysis. Huawei Cloud MRS is versatile in handling various big data workloads. It excels in large-scale data analysis, processing vast data sets for insights. For instance, analyzing petabytes of climate data. Maybe you need to make an ad hoc query with the climate data. So you can use MRS effectively. Large-scale data storage, of course. MRS also shines in large-scale data storage, offering high-performance storage and query capabilities, of course. For example, storing, querying petabytes of vehicle data for real-time insights in the automobile industry is possible. And of course, real-time data processing with the built-in tools like Spark, like Kafka, you get your real-time requirements with MRS. So, if you are familiar to Huawei Cloud Services, MRS's relations with the variety of services that are available in Huawei Cloud. ECS, of course, it means Elastic Compute Service, a virtual machine. And MRS uses Elastic Cloud Service as cluster nodes, as master nodes, as worker nodes, as data nodes. OBS, we have OBS, object storage. OBS stores MRS job inputs and outputs data, including user programs, data files, result files, log files. And MRS components like HDFS, Hive, MapReduce, Yarn can interact with OBS data. And MRS leverages OBS's parallel file system. RDS, of course. RDS is used for the storing metadata of the cluster mainly. And CTS, it's a cloud trace service, and it provides you with operation records of MRS resources from the users, like querying, editing, auditing, and backtracking. And SMN, simple message notification. MRS uses SMN to provide one to multiple message subscription and notification over a variety of protocols with variety of communication endpoints like phones, emails. So let's talk about the APIs and SDKs. MRS also provides a comprehensive set of over 50 RESTful APIs and SDKs for efficient cluster management and enabling tasks such as cluster creation, cluster scaling, auto-scaling, policy configuration, cluster viewing, data movement. You can review the API documentation if you want to get further information for that. So, in this section, before moving further in this section a water. In this section, we are going to view of the MRS console in the Huawei Cloud. I have already purchased a cluster before this presentation because it's a time-consuming job. It takes half an hour, so I have already deployed it. But don't worry, I will show you step-by-step instructions when buying the cluster. Okay. So yeah, there are the steps here. For now, we are quitting from the presentation and go for the cluster. Where's my browser here? I guess. Yeah, here. So, first of all, first things first. First of all, you after login to Huawei Cloud, timeout issues, maybe. Give me a second, please. After logging into Huawei Cloud Console dashboard, just click the hamburger icon and type MapReduce, or you can find it from here, from the where is it? Yeah, here, analytics services. Okay, here. Just type here MapReduce if you know the service exact name. Go for it. Yeah. So as I said, I have already bought a cluster, but I will show you the buying a cluster page and configuring it and put some data to our cluster. So the first thing is clicking here with buy cluster. Yeah, there are some tips, pop-ups. Click pay-per-use. You can give a name from here. Cluster type, custom cluster, streaming cluster, hybrid cluster. You can choose version type from here. Long-term support is more robust. You can go with how to analyze cluster. I don't know. It's up to you. It's up to your workload requirements. But for this demo, I use this one. You need to choose availability zone for the MRS cluster, an enterprise project. Use your VPC and its subnet. You can configure your cluster configurations from here. These are the master nodes. These are the worker nodes. Master node for the cluster monitoring and client connections, and those guys, worker nodes, node group. It mainly stores and processing the data. You can change the node flavors from here. You have also a memory optimized flowers options. Kerberos for let's say authentication, but no need when you working with a POC or demo environments. We have already defined a username. We need to define a password, authorize this box, and just click buy now. But I must say it's even it's pay-per-use service. As you can see the configuration of the nodes, it's a little bit expensive, but if you let's say long-term usages have long-term usage requirements, you will have definitely be cost effective when using this service. So now loading failed. Please reload. Okay, let's wait. Where's my cluster? Yeah, here. Let's click here. And it's dashboard. We have tabs like summary, notes, master notes, worker notes, and it's their summary information, like name, like IP, like specification. We have components. In Hadoop Analysis cluster, we have Hadoop Hive, Spark, Flink, DB Service, Zookeeper, Ranger, and Test. We have some backlogs, alarms, patches, files in our HDFS file system, as you see. Okay, when after provision completed and this cluster is running, you need to access here. Okay, access manager. I have already defined Elastic IP, public IP for reaching this cluster, but when you first use it, it says you need to bind an EIP to it. Don't worry, bind it. It's okay. And after this job done, you can get this page and log into like that. Oh, a lot of passwords. All right. So you can view your clusters, components, situation. Here you can view and monitor your nodes, CPU usage, disk usage, network usage from here as well. But when configuring for the clients, you need to click here and you need to click down on client for the client configuration. Click here. It's a default temp. It's okay for us. Say okay. And it produces a client files for the client configuration. After it is done, go back to your cluster page, click the nodes, click the master nodes. In default, the client files uploaded to one of the master nodes. In this POC, it's uploaded to here. Let's wait for a moment. Remote login to your node. Log into your node. So the first things are first. As you may remember, the client file was uploaded to this location. Let's see. Yeah, here in the 10th row. I have already unzipped the client files, but the exact commands for that I can show you from here. You need to first tar this file and tar this file, then and go change your directory to this one, and run your installation script into this file, into this directory, and go to this directory and initiate your big data. After initiating, oh, it stopped. Okay, let's start it again. Interesting.
Eyvallah abi. Bir exception attırsanız uygulamanıza. Attırabilir misiniz?
Evet.
Yanlış bir şey yazalım.
Hmm.
Exception atmaya ya uygulama gözükmüyor. O kodu yanlış yazarsan olur.
Yeah.
Direkt yanlış yazalım.
Here.
Birisi.
Source it. Yeah, as you can see, they are all working. The MRS components like runjar, it's a Hive service, test services, bootstrap server, and name nodes. After configuring the client, let's upload some files into our HDFS directory. Sorry for that, but I already provisioned the directory. Yeah, as you can see, we have some predefined directories in the user directory. I have also deployed a new directory called cold storage for this demo, but let's make another one and give a name like warm storage. All right. First thing first, let's check the MapReduce file system. Yeah, it appears here. But there's nothing here for now. Let's put some files into here. So we have the test file. Let's put it to our file system.
Mobil kısmı kafamda oturtturamadım.
What was its name?
Aslında o kısmı oturtursam 2 dakikalık kodlama da. Oturmayınca da oturuyor işte bazen.
Warm storage. User warm storage. Here we have one.
Mesela bunu niye yapıyor acaba ya? Yok.
Interesting.
Çok garip. Ben bunu New York'ta test ettim. Yok. Bunu kodladım ya. Bunu kodladım. Şey yaptım. Bunun zaten böyle bir şey olacağını biliyordum. Ben onun için ayrıca kod yazdım işte. Eğer ekran büyürse tarzında bir şey yaptım. Bak oluyor. Bazen gelmiyor. Bak mesela oluyor. Sıkıntı yok.
Interesting. Why not working? Ha.
Onu hallederiz ya. Sıkıntı değil. Onu hallederiz ya.
Oh.
Bir olup bir olmaması
Just forget the choosing the file that I need to put. Sorry.
Bak gitti. Milyon kere bastım olmadı. Acaba
Bekliyorum açacağım.
dur. Şey buldum sanırım.
It's okay now. Nice. So let's check it.
Ekran boyutunu gidince bak.
We used the cold one. Sorry for that. Let's go back to user directory and yeah, here. So that's all for the console side. You can easily deploy your cluster, MRS cluster from the console, and you can easily monitor and manage it from here. So let's get back to our presentation. We have remaining few simple remaining slides. So I'm skipping these parts. So we have quiz. We have 2 questions about this session presentations. You can give your answers from here, from the chat box. So the first question is about Huawei Cloud MRS is primarily suitable for small-scale data processing tasks. True or false? Just give your answers from the chat box. Let's wait for a few seconds.
Kendinden mi yaratıyor başlarına?
Tamam.
Okay, I think everybody may have some answers for the question. Let's giving the answer and discuss why it's true. So the first question's answer is false, because it's ideal for big data. It's not for small scale. Yeah, you can have small scale data processing, but it's not feasible. The second question, the multiple answer question. So we have more than one true answers. Which of the following is not a core component of Huawei Cloud MRS? HDFS, Kafka, Yarn, and MapReduce. Oh, single answer questions. It's, by the way, not multiple answers. Which of the following is not a core component of Huawei Cloud MapReduce? It's a difficult one, by the way.
Çok şey değil ya.
Yeah, the answer for this question is B, Kafka. Yeah, I know. You are going to say, you said in the presentation, there is Kafka in the template. Yeah, there is Kafka in the template, but HDFS, Yarn, and MapReduce are the core components, and they are available all in the templates. But Kafka is not available in all the templates. When you want to provision a simple and basic MRS cluster, you have HDFS, Yarn, and MapReduce in default. Okay, so the correct transfer is Kafka. So, with this presentation, we provide you a comprehensive overview of Huawei Cloud MRS. It's a powerful platform designed for processing, storing, analyzing vast amounts of data. We explore MRS core capabilities, key features, and benefits. Additionally, we delve into real-world application scenarios to illustrate our service value. We also define some APIs and SDKs and get some console job in the Huawei Cloud Console. So, thank you for attending this presentation. If you have further questions, you can ask me. I will answer your questions. So, in the feedback slide, we have a QR code here. You can scan it for the feedbacks if you have. Thank you for listening. I think we have some time. If you have some questions, I can gladly answer them. Yeah. Any questions? No? All right. It seems we have no questions. Okay. Thank you for listening. Have a good day. Bye-bye.